Okay, welcome to the first YouTube video. I just want to do some sample physics problems, and hopefully you'll get some insight into how I take apart problems, and hopefully it'll help you on your homework. I actually posted the PDFs of these problems, but I kind of want to do kind of like a video chat walkthrough of my solution and kind of what I'm thinking at different times. So this is the first problem, problem 25. I got a river flowing south. So this is the first thing that catches my eye here. It's rivers flowing due south. So in my mind, I'll just sketch it up here. I'm going to have some kind of river thing, and it's going in this direction. And it says it's got a speed of 2 meters per second. Notice it doesn't say a speed relative to blah, 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 blah. So what I'm interpreting that to mean is it's 2 meters per second relative to Earth. So it's kind of like what we always assumed before. So this is 2 meters per second. And what I really should say is maybe that's going to be like the velocity of the river relative to Earth. So R is river, E is Earth, something like that. And then it says a man steers a motorboat across the river. Velocity relative to the water is 4.2 meters due east. Okay, meters per second. So I got a boat here, or something like that, and it's going this way, and it's 4.2 meters per second. But here's the thing. It says velocity relative to the water. So in my mind I'm thinking, okay, that's not velocity relative to the Earth, that's velocity relative to the water. So in my mind I'm thinking velocity of the, I don't know, boat relative to the water, something like that. And the river is 800 meters wide, so this is something like 800 meters. This is just a quick sketch. I'll show you the cleaned up version, but this is kind of what's going through my mind. I'm trying to take apart the information they're giving me. First thing they ask for is what is his velocity, which is both magnitude and direction, relative to the Earth. Okay, see, so that tells me something. This is definitely the velocity of the boat relative to the water. What they want is the velocity of the boat relative to the Earth. And we don't know that. All right? And then these other questions we can figure out later. How much time is required to cross the river? How far south is the starting point? So let's go through this and see what we can find out. So here was my solution. What I first started out with is I started out here. Oops. Where's my stuff? Ah, there it is. Sorry, my bad. Here we go. I started out defining what do I mean by E, R, and B. This just tells me the reference frames I'm talking about. Earth, river, and boat. And then I do my drawing. And here you see my 2 meters per second river water flow. Here's my boat with my dude in it, and here's the 800 meters. And then I set it up so that this is the x direction, this is the y direction, as you can see that right here. And what they tell me is the velocity of the boat relative to the river is 4.2 meters per second east, so I put that here. And the velocity of the river relative to the Earth is 2 meters per second south, that's what I put here. Okay, so the first part of the question is what is the velocity of the boat relative to Earth? So that's what I want, and I think this is the hardest part of the problem right here. Figuring out what do you want to write, and so what I said is the velocity of the boat relative to the Earth is going to be the velocity of the boat relative to the river, which is what they give me, plus the velocity of the river relative to Earth. Now why did I choose that? Because I see this B over E here, and here I see a boat river, and then I see a river Earth. And yes, I know it's not multiplying, but I imagine these subscripts to be multiplying each other, and then what I see is this R and that R cancel, and I have a B over E on both sides. That just kind of gives me some assurance or some feeling that, yeah, you know, I did this whole relative velocity thing correctly. So then what I did over here is draw a picture of that, a vector diagram. So I know that my velocity of the boat relative to the river is 4.2 meters per second east. So I drew a line. That's what this guy is here. I didn't even draw it to scale, but that's to the east, and it's 4.2 meters per second. I also know that the velocity of the river compared to the Earth is 2 meters per second. And so these two vectors together, that's what represents the right-hand side of this equation. And so what that tells me is, oh, the left-hand side has to be this. You add those two vectors together, right? Tail to head, tail to head. I'm going to get this thing. So that is what we're talking about right there. We're talking about the vector or the velocity of the boat relative to the Earth. Okay, let's move on. All right, so now that I have this nice little triangle over here, uh, I just called this angle theta because I need to call it something. And that's the angle in this triangle. And I noticed that, look, I have the opposite side and the adjacent side. So I'm thinking tangent. So the tangent of that angle is the opposite, 2, over the adjacent, 4.2. And then I just solve for theta. Theta's inverse tangent, 2 over 4.2. Plug it into my handy-dandy calculator, and I get 25.46 degrees. You know, I probably should have rounded that to 25.5, but I kept 2 digits. And the way you describe it is this is south of east. So the east, that would just be straight this way, but then it's dropping down a little, so that's kind of like this way. That's why you say south of east. So it's 25 degrees south of east. That's the direction. Then the question is, well, what's the magnitude, right? Because in order for me to fully describe this vector, I need direction and magnitude. So the magnitude, since I have these two sides, I can use the Pythagorean theorem. And that'll be the magnitude of my overall velocity vector. So I take 4.2 squared, add it to 2 squared, then take the square root of it, and I end up with 4.65 meters per second. Right there. Okay. Okay. The second part of the question was, how long does it take to cross the river? And the thing to notice here is, yeah, this thing is drifting downstream, but only the velocity that's in this direction helps it get across the river. It could go downstream for miles, and it's not going to change. It's only the velocity in this direction that helps it get across the river. And so it's only this velocity, that 4.2 meters per second, that it's actually moving it across the river. So I'm going to use that and say, okay, look, only the velocity to the east helps cross the river. So my position at any time, if I start measuring from the left side of the river, like over here and I'm going over here, I might be drifting downstream, but I don't care. What I'm worried about is how far over do I get each time. That is my velocity in the x direction times time, and that's 4.2 meters per second. So I just plug in those numbers, 800 meters for x, 4.2 for v of x, and t I don't know, but I can solve for it. It's just going to divide both sides by 4.2. It's 800 over 4.2, and I end up with 190-ish seconds, so about 3 minutes, a little bit more than 3 minutes. The second question is, how far south is my starting point? Because, right, if I have this river here, and I'm over here, as I cross this way, I'm also drifting downstream. And so what they're asking me for is, how far downstream do I actually drift? Ideally, I could have gone straight across, but I didn't. I went downstream, and that's going to be determined only by the y velocity, or maybe I messed. Did I might have switched x and y in my talking, but what I mean is it's only this guy, the downstream 2 meters per second, right? This guy here, that's going straight across. It doesn't move anything downstream. It's only this guy here that moves stuff downstream. So I can kind of say the same thing. The distance south then is y, is velocity in the y direction times time, so that's 2 meters per second. And then the t, I just took that from this answer up here, from my previous part b, multiply those together, and I get about 380 meters south of my starting point. And that's the problem. Hope that helped. Thanks.